Is the following series convergent or divergent? First of all, do you recognize any pattern here? Remind yourself of geometric series, which is denoted by the summation of a r to power n minus 1 and start from 0. And start from 1 goes to infinity. You're going to use 0 later. And if the ratio or r has the following property, that absolute value of r is less than 1, or r is basically bounded between -1 and 1, this series is convergent to a divided by 1 minus r. So let us rewrite our series so we can recognize this pattern. This can be written as the summation of, well, I have e to the second power raised to n divided by 6 to power n times 6 to power -1 and start from 1 goes to infinity. If I take these two, I can form a new fraction. This is the summation of e squared divided by 6 to power n times 1 over 6 to power -1 and starts from 1 goes to infinity, which in turns can be written as the summation of e squared divided by 6 to power n times 6 and starts from 1 goes to infinity. I just flip this guy. So what do you get? You get 6 times the summation of e squared divided by 6 to power n, right? But what do we see here, right? E is a Napier number and starts from 1, goes to infinity. What is the approximation for Napier number? Remember, your ratio here is e squared divided by 6. E, or Napier number, is about, we are using approximation 2.71. If I'm correct, 82. I don't remember the rest of the numbers. This is an approximation for your Napier number. So if you take Napier number and multiply it by itself, let me use a calculator. You get about 7.3890. So e squared. E squared is about 7.3890. So now let's take a look at the ratio. Our ratio is 7.3890 divided by 6, which is indeed more than 1. Well, since the ratio is more than 1, we say that, hey, this series is divergent. So this is your conclusion. Since in this geometric series, the absolute value of ratio is more than 1, so it means that our series, the summation of, what was the question? The summation of e to 2n divided by 6 to power n minus 1 and start from 1 goes to infinity is divergent. So make sure to break down your general term in a way that it resembles the geometric series. When you have geometric series, you know how to deal with the geometric series. You have a ratio. If the absolute value of ratio is less than 1, or the ratio is bounded between -1 to 1, then for sure you can say that, hey, this series or this geometric series is convergent to a divided by 1 minus r. So first, make sure to rewrite your series the way that you can recognize the ratio. The ratio in this case is e squared divided by 6. It's not e over 6. So when we use a calculator, we know that for an Napier number, it is 2.7182. If you raise it to the second power, is 7.3890. When you do the division, the ratio is more than 1. So since the ratio is more than 1, you're going to say that, hey, this series is a divergent series in nature. You could take the limit as well. So let me write this note down here for you. Note that the limit of e to power 2n divided by 6 to power n minus 1 as n goes to infinity with the same argument. Since e squared, this is, if you want to write this in a way that is comparable, it is e squared to power n divided by 6 to power n minus 1 as n goes to infinity. And since this number inside parentheses is more than the base on the denominator, which is 6, it means that this limit goes to infinity. And you're going to say that since the limit of the general term in the series is not 0, so our series is a divergent series. Different types of questions for a series like this. If the question says recognize a pattern, you must be able to say that, hey, this is a geometric series with the ratio r, which is e squared divided by 6. If the question says, hey, is it convergent, divergent, you can also take the limit of the general term and say that, hey, since the limit of the general term is not 0, so the series is a divergent series in nature.